Hello everyone, welcome back. In this video, I am going to be walking you through some information about the Unit 3 Little Review Book. So if you notice something that's a little bit different than the last two units when we did this, or I'm not physically in the video, right? So I'm not showing you how to make the little book, right? Or like weaning you off of it. The first time we did it in class, the second time I showed it in the video, and now I'm still going to show you what we want in the little book, but I'm not going to show you how to make the little book. If you are not confident with how to do that, we don't give up, right? We don't just not do it. That's not cool. What we do instead is maybe we go back and we watch the old video. Maybe we ask a friend or a sibling who might know how to do it, or we Google it, or you come in to see your teacher to get some help with how to make it, right? Because we still expect that you are making it. It's still something that you're submitting to us. In fact, it is still 5 points. It's actually part of your test grade this time, okay? So Unit 3, which was Matrices, and then by your name and feel free to decorate as you see fit. So I'm going to kind of go in order of what we did, and as has been the case with the other units, like your job is to fill this stuff in with what you need, what you practice. As I've shared, or as we've shared several times, like this is a great way to organize your notes while you're not going to be using it on this assessment this time. It gives you something to go back and reference later on, and it does kind of just compile your notes and your ideas all into one place, and sometimes writing things down helps you remember it, right? So what we started with in this, and notice I don't have anything about notations. That might be something that you want to add in here. Maybe, right? Like that's really what we talked about with different notations, and we talked about what different, I don't know what that is, but we talked about what different things meant. So you might want to add a piece of that in. I don't know, up to you. You might also be able to scatter that in. And so what we started with was just these basic operations, right? So we did addition, subtraction, and scalar multiplication, which were basic operations. And maybe something that you want to do here, some examples, right? Maybe you want to talk about how the dimensions need to be the same. The dimensions, or sometimes that's called the order, how it's rows by columns. Right, so if you have a matrix and so those and the entries of it. We also, when we did this, we talked about matrix equations without inverse. And so what I mean by that, like without inverse, is that's very annoying. There must be like something clickable back here. We did stuff where it was like, maybe I had 3, 4, 8, -2, and I was going to add a matrix to it, and it was going to equal to 7, -6, 4, 3, right? And just treating it like any other equation that you know, and we'd subtract it from both sides, right? So being able to solve for the matrix. One of the separate ones, right? So like these were just the basic operations. And then over here, I have matrix multiplication, right? Which was a little different. So think about what the criteria is, right? It's not commutative. If you do A times B, it's not the same thing as B times A. The only time that would be true is if you're multiplying by the identity matrix, right? It's not commutative. Remember the columns must match rows. So without even doing the multiplication, you can tell, like, can you multiply it, right? Or is it undefined? Be careful here because you're going to have a calculator, and your calculator might say something about like it being mismatched. But really, if you can't multiply, it's undefined is what it means, right? That's an important word for us to recognize, that we're not like real, right? That's why the calculator is a resource. Things like you should show your work matrix, right? And I would probably, like, mine's super messy. I would certainly hope that this is not the little book that I would be turning in. I'm just kind of spitballing some ideas. But I would probably include an example as well, right? I would write some important notes to myself and then include an example of matrix multiplication. In fact, I might include a challenging one, right? Whether I want to make one up so that I saw, here's the work matrix. This is the work that we would expect to see. The calculator is there as a resource. However, we should still see the work, right? All of these things that we learned, we should still see the work when you're producing it. Okay, so what do we do after this? We talked about determinants, right? We actually did this in a slightly different order, but I grouped them together. So we did 2 by 2 determinants, and then we talked about the multiplicative inverse of a 2 by 2, right? And we talked about the adjoint and then solving 2 by 2, because that was all by hand before we talked about 3 by 3. But now that we have all the knowledge, I'm just going to group these together. If you have a way of organizing it slightly different on yours, that's totally fine, right? So maybe with the 2 by 2, we want to do an example. And with a 3 by 3, we want to do another example, right? Our calculator can do these for us. And again, that is a great thing to check. But I would make sure that you know how to do it by hand, right? So I'm really just going to emphasize, show your work. Right? So maybe I would say, like, I would use this page and probably do 2 examples. Do an example of 2 by 2 and an example of 3 by 3. Think about that word singular. There's a really good vocab word. A singular matrix is when the determinant equals 0, which means that there's no inverse. This might be a good place to include that information, or maybe you want to include it over here on the next page. What was I going to say? It does not matter which method you choose to use for the 3 by 3 determinant. You can actually use the one with the cofactors, or if you want to use that shortcut where you take the first 2 columns and slide them over, that's completely acceptable as well, as long as you're able to find it by hand and show your work. If you're looking for something a little bit more challenging, maybe think about something like, oh, right, like we had something on the quiz where, oh, the notation for determinants is really important, right? This indicates determinant. This is a scalar, meaning it's a number. So if you're asked for a matrix, it should be, this is what a matrix looks like, this is what the determinant of a matrix looks like. They're not the same thing. They do not mean the same thing. Be careful with that notation. What was I going to say? We had something on the quiz where, I don't know, we had something like 2, 4, E, 7, 9, 10, -1 or something, and then equals to -4, you have to solve for E, right? So maybe you want something that's a little bit more challenging. Then we talked about, or with this, we talked about the identity and the inverse, the both multiplicative and additive inverse, right? So the identity matrix is the one that has 1s along the main diagonal and 0s everywhere else. And if you multiply anything by the identity matrix, it keeps its identity, right? That's going to equal to I. That's going to equal to A, right? Or if I multiply something by its multiplicative inverse, I'm going to get I. This is multiplicative inverse. It's just like multiplying 3 times 1/3, and I get 1. The identity matrix is essentially just 1. Not dividing, it's just 1. I'm multiplying by the multiplicative inverse. The additive inverse is the one that's going to get us the 0 matrix, right? Like the additive inverse of 3 is -3, because it's going to give us 0. So if I had like 2, 4, 9, 12, 16, 3, I could have an additive inverse of this of -2, -4, -9, -12, -16, -3, because that's going to give me, sorry, now I'm out of room, the 0 matrix. I guess for the determinant, I maybe should have included only square. Right, so that goes with this, the multiplicative inverse, only square. We don't need to be able to figure out the adjoint for a 3 by 3 matrix, right? So it is important that we know how to do it by hand for a 2 by 2, but for a 3 by 3, while we want to be able to find the determinant by hand, we don't have to find the whole inverse by hand. That's something that we can let our calculator take the lead on. We just need to know, how do I indicate on my paper that I did it? And it's not that you have to continually write a matrix over and over. That's something that takes time. You're able to write the name of the matrix and say inverse. So then we did 2 by 2. I mean, I'm a little out of order, but 2 by 2 matrix equations with inverse, and this is by hand again, right? So knowing that the inverse is equal to 1 over the determinant of A, times the adjoint, right? So if it was, I mean, I guess I'll just write it like this, A, B, C, D. This is D, this is A, this is the opposite of B, the opposite of C. I would write an equation for myself, or an example for myself, sorry. Matrices in a calculator. Really, the key things are you want to know how to do an inverse. You want to know how to store it. You might want to write notes to yourself so that when you get to pre-calculus next year, or when you get to some higher level math classes, if you pull this out, which I hope that we're creating these with the intention of wanting to do that, great resource, that you're like, I don't remember how to enter a matrix, but you can just pull it out and look all in one place. Right? So how do you store a matrix? How do you recall? How do you edit it? Inverse is a really big one. Doing like multiplication. You don't need to be able to add and subtract and all of that, right? You'd be fine by hand. You need to be able to do the multiplication by hand anyways. If the determinant equals 0, there's no inverse. We had some really good explanations, like some people did a great job explaining that it would be 1 over 0, which is not possible. Many of you guys use the word singular. Right? Those are great things. And then we got into some IB style matrices, and you actually saw a variety. There was a worksheet, and I would go back and maybe write some notes to myself of what does IB expect to know, right? You have a document. You have several documents that have to do with this. If you don't feel that you want to include this, I would really encourage you to write some key things to yourself about what IB wants and expects you to be able to do and all that. And maybe here you're just going to include a challenge problem for yourself, one that you found challenging that you figured out how to do. Or let's say you didn't figure out how to do it yet, that you're going to come in and ask for help with. Okay. And finally, solving linear systems with inverse. Again, if it's 2 by 2, it should be by hand. If it's 3 by 3 or larger, it's in your calculator, right? And so you should be writing the matrix equation. That should be a habit for you, right? Write the matrix equation. If I give you 2x plus 4y equals 9 and negative x plus 6y equals 12, my first, regardless of using a calculator or not, I should have 2, 4, negative 1, 6 times xy equals 9, 12. That should be there, right? This is one that I would have to do by hand. But you could, it's fine to then write out, okay, well, I know I'm going to do x equals, well, not for a 2 by 2, but if it was a 3 by 3, C inverse times A. Coefficient, variable, maybe I wanted to call this V, sorry. Answer. The coefficient, the inverse of the I would have to left multiply, right? And that's an important piece. That's something that even came up on that IB paper, on that, what IB expects you to know and be able to do. Okay. 3 by 3, you're more than welcome to use in your calculator, but you should still be showing work. You should still be showing this piece of it. Maybe you even remember, and this is actually really good too to talk about, maybe you remember what it's called. We don't want to forget that stuff, right? Independent, consistent, dependent, consistent, and inconsistent. Right? If there's a solution, if I get an xy, my answer should be written as xy. It should be written as a point. That would mean it's independent, consistent. If they're scalars, right? If I can multiply by something and get the other one, that means that it is dependent, consistent. They're equal. That would have to be true for all of them, all 3 things down the line. If they never intersect, so like if the slopes are the same, but different y-intercepts, I would end up with, inconsistent, right? Those are good things to know too. In this place where I wrote other notes, I know some of you guys had the opportunity to explore, you chose to explore Kramer's rule, and you chose to explore Gauss-Jordan, or Gaussian elimination, which is challenging. You might want to write some notes to yourself there that will be useful in the future. I want to really just emphasize that we're not, if you didn't explore either one of these, or these are things that really just didn't make sense to you right now, that's fine. You're not going to be held accountable for knowing those. However, you will be given an opportunity to show that you know that and show that you learned that on the assessment. Okay, so if you want to include that in your notes, go for it. So what your job is to complete your little book and then submit your video to us. We do expect in that video that you are talking through it, right? That you're explaining to us and sharing with us what is in your little book. We want to see that and we want to hear that. We also believe that it is it really helps you sometimes commit things to memory and understanding if you are talking and explaining things through it. So we really look forward to seeing these. And again, this is actually added into your quiz grade. So please make sure that this is submitted before your assessment. It will close when you arrive at your assessment. Right, so we can't wait to see these. And thanks for watching. And we will see you next time.